Uh, the symposium is organized by Tokat Gazi Osman Pasha University from Turkey, and the symposium is technically sponsored by IEEE Turkey section. Thank you for your scientific contribution and support to the symposium. Now, if you want, let's start the session. First paper belongs to Dear Wen Wang. Dear Wen Wang, are you online? Can you hear me? We can expect participants to attend for 1 or 2 minutes. Dear Isaac Daniel Milano Coro, are you ready to present your study?
Of course, I can start.
Okay. If you are ready, you can start your presentation. You can share your screen. You have 10 minutes, please.
Okay. Please confirm you can see my screen.
Yes.
Good morning. My name is Isaac, and I'm here to present our paper on geolocation and virtual reality to streamline the management of hydrographic basins of the regional agriculture management of La Libertad, Peru. As introduction, regional management of agriculture in La Libertad implemented the regional program Siembra y Cosecha de Agua. That means water harvesting and cultivation. It's rainwater in artificial lakes. During the implementation of the program, through technical and field visits, various issues were identified in watershed management, such as delays in mapping, slow reports generation, lack of information control, repetitive manual process, and high operation costs in report generation. Additionally, the lack of the appropriate organization and processing structure was observed. And another issues relation of this. On the previous studies, in the context of watershed management, the use of innovation technologies has proven to be highly useful in streamlining process and improving efficiency. Some relevant precedents in this field is present in designing virtual workplace using Unity game engine and designing development of a web-based interactive twin platform and watershed management, and virtualizing construction of wetlands, a case study of Poyan Lake in China. The article described the challenge of creating a dynamic visualization through three-dimensional models and present a workflow of the construction. The general objective of this research was to streamline watershed management in the regional management of agriculture in La Libertad through the implementation of a geolocation and virtual reality system. To target this objective, indicators were query time for specific information, report generation time, operation cost in reporting, and employee satisfaction level. About materials and methods applied for the development and implementation of software project present as a solution for this research, the Agile methodology Scrum was used, aligning with the PMBOK as a framework to management projects. We can see geolocation and VR software implementation architecture. As backend, we use APIRES, building by Laravel framework, and front-end Angular framework. For VR application, we use Unity 3D, Oculus SDK, and a library XR interaction toolkit. And for mobile application, we use also Angular framework, but a new method we call progressive web application. Regarding the development of virtual reality, the Unity game engine was utilized as it allows for the construction of 3D models and integrate various tools and libraries for this type of application. We can see workflow of a virtual reality application with Unity. The system, we present a solution responding to user requests without delays and being available with need. We can see function requirements in these categories: security, management of watershed components, geolocation, basins and components, visualization of basin components in virtual reality, and reports. The research used a pre-experimental design consisting of a pre-test and post-test stage. This design involving measuring the dependent variable before and after the application of the independent variable, in this case, as a solution. Indicator 1, the study population considered 2,700 specific information queries, from which a sample of 336 queries was selected. For indicator 2, population were 360 reports, and a sample were was 186 reports was selected. For indicator 3, the population were 360 reports, and the sample was the same, 186 reports. For indicator 4, to measure satisfaction level, the population were 8 collaborators of the company. To validate an instrument, in this case a survey, the technique of Judge's criterion was used. For this purpose, Kendall's W coefficient of concordance was applied, and a positive result was obtained, ensuring agreement among the judges. We can see a resume of the results of the inter-judge agreement test applied to variable-dependent watershed management. P-value obtained was 0.020, what is, and the Cronbach alpha also to apply to a dimension of the variable dependent, dimension 1 information, operation, communication, and compliance. And the result of Cronbach alpha was 0.96. About the results for indicators, for 3 indicators were normally test, Kolmogorov, Smirnov, Lilliefors. For indicator 1 is after measure pre-test and post-test, p-value was 0.0116. For indicator 2, p-value was 0.0992, and indicator 3 was 0.5915. For indicator 4, normally test was Shapiro-Wilk, and the p-value obtained was 0.3695. And the comparative results for indicators was indicator 1, query time for a specific information was measured in seconds, we obtain an impact of minus 102.86. Total result was 97.95%. For indicator 2, report generation time measured in seconds, the impact was minus 299.97. Total result was 98.94%. For indicator 3, operation cost in report generation, the impact was minus 0.1166. Total result was 98.83%. For indicator 4, employee satisfaction level and scala Likert 1 to 5, the impact was plus 2.65. Total result was 53%. We can see three applications was building: a web application for monitor vaccines, an Uber application, we building virtual scenarios, and we can see lakes in these places, and a simulation too about we want see in the future. And mobile application, we can see common reports which important for the company. Conclusion. For the indicators to aim, the general object was the level of satisfaction among employees before the development and implementation of the geolocation and virtual reality system was 1.86 on a scale 1 to 5. After the implementation, it increased to 4.51, resulting in a positive impact of 53%. The average time for accessing specific information before the development and implementation of the geolocation and virtual reality system was 105.53 seconds. After the implementation, it decreased to 2.66 seconds, resulting in an impact of 97.95%. The time for generating reports before the development and implementation of the geolocation and virtual reality system was 303.48 seconds. After the implementation, it reduced to 3.51 seconds, result in an impact of 98.84%. The average cost for generating reports before the development and implementation of the geolocation system was 0.1179 soles per second. After the implementation, it decreased to 0.040 soles per second, resulting in an impact of 98.83%. Thank you. I appreciate your time and attention.
Thank you very much for your presentation. Dear participant, do you have any question about the study? Okay, no questions. Thank you again. I wish you success in your career.
Thank you.
Next paper belonged to dear Elizabeth Ango Fomuso Ekellem. Dear Elizabeth Ango, are you online? Okay. The next paper belonged to dear Vinay Kumar Garg.
Yeah. Hi.
Okay. Are you present?
Yeah, just a moment, please. Yeah.
Okay.
Let me share my screen. Okay, so just let me
Please,
know if you
you
can
have
see
10
my screen.
minutes at
Yeah,
most.
if you can see my screen, just please let me know.
Yes. Yes.
Okay, thank you. Yeah, so this is about the automation and vehicle tracking through RFID and barcode system. So what we the contents about that how we are getting this particular solution and how we got the problem statement, how and we got the methodology which we can produce. So this is the coal-based power plants where coal have the um, quality which is called GCV, gross calorific value, and in that case that which is impacting the environment law as well. So how we can go ahead to reduce the manual intervention and which we can use, and we are reducing the manual intervention through RFID, which is called radio frequency identity, and plus barcode system. Barcode system is just one thing that we can have a GCB value where the chemical department can have a outcome of that, then how much power we can generate from the GCB value. So these are the things which we have implemented. We have already the SAP system, which is the identical, and barcode and RFID have different applications which we have integrated to get our quality as well as quantity both. So here you can see that the a lot of manual work was done inward and outward, both kind of thing. In that case, a lot of manual checks are already there, and uh, while route there are a lot of mine to plant. There are suspicious activities like, just for example, uh, coal theft and a lot of these things. So in that case, logistic team have to be get the manpower, and quality of material also compromised due to some kind of suspicious activity. Uh, so we have pro proposed that we can have a barcode system. Barcode system was working in plant, which vehicle tracking was not possible in that case. And what we introduced that RFID system. After plant, in plant, we can have a we can manage that in plant movement of the vehicles as well. So in the second paragraph, you can have read about that why we have done this, because there are a lot of manual intervention during coal and ash truck inwards and outward data entry and payment process. And detection of QR codes is randomly acquired images linked between online information and actual items are created to allow for RCI, rich content interaction. So what we did in power plant gate entry time, we have produced the RFID. Same time we have given the barcode system. So RFID is giving you have the quantity of the code, and barcode giving you the quality. And at the same time, we have the database. One is SQL and sorry. RFID and barcode both have the SQL database, and the SAP have the Oracle database. What we have done, then the first bridge which comes with the coal and sampling point, and then barcode, and uploading point, material gate, web bridge, and again it's out to the gate entry. So in that case, we merge all three databases with replica, mirror image, we can say that. And here, if you can see that we have mentioned all the master data which are already available in RFID system as well as barcode system and even SAP also. So what we did that SQL database, we can have a mirror image, but yes, WebBridge 1 and WebBridge 2 that are giving us the real quantity of the coal. And in that case, what happens once it's goes out of the WebBridge 2, once vehicle is empty or unloaded, and that case we can have a auto GRN, good receipt entry, we can say that in SAP. And for that algorithm, we used gate entry, which was not earlier used. There are some remote functional calls which we have created in SAP, and there are some updates in customized table, or we can say that Z tables that we have done that. Uh, so these kind of data, we created two tables, and in non-SAP system as well as SAP system both. And if you can see on the third row, gross weight minus tare weight of the vehicle is the uh, normal weight, material weight of the coal. So this is the algorithm which we have used. This is the basic point, gate entry number, where we have get the master data, and then RFID generation, then barcode generation, and then gross weight. And this is and once we got the tare weight, we can have a weight of the material. Here we have added one functionality that if you can see that after gate entry, once it's saved from the WebBridge 1 to WebBridge 2, we get the GRN number, which is systematically automated by ourselves. This is the second algorithm, checking in SAP, checking predefined fields, generate GRN number. So this is the total automation from the three fields. What we got after doing this, these are the presentation from my side, that what we got. With the help of SAP ABAP, which is the technical term, and SAP configuration, that how we got. And this is the system which we have used at the gate point, web bridge point, as well as sampling point. So this is the system configuration. Third one is how we have used the RFID and barcode. I think it's not clear, but we can have a direct, we can have a live system, that how many trucks or how many vehicles are inside the plant. So this status we can check, and which particular point they are available. And these are the number of vehicles, how many trucks are in which particular location. Yes, we can have this kind of analysis also, that we have done barcode, RFID, and RFID plus barcode plus SAPs. So now if you can read that barcode one at a time, because we have using it since 2019, RFID 10, hundreds or thousands simultaneously, and RFID plus barcode, that we can have a one in a time. So in that case, barcode we can't use, reuse, and RFID we can use, because we have taken the manual one. Read range is also, sorry, read range is also from inches to feet for barcode, and passive UHF ID 10 to 30 feet. So, and this particular RFID plus barcode plus SAP, we can use 50 feet. Speed quite slow using barcode, but RFID and RFID plus barcode and plus SAP, it's quite fast. If we can compare these things, number of vehicles, manual entry, barcode, RFID, and RFID plus barcode plus SAP. So we have achieved an manual intervention is very less. And in that case, we can have less number of people, less number of manual intervention while tracking the vehicle. So this is the this project me and my team have done, and this project we have integrated all three systems, which is RFID, barcode, and SAP, and we have achieved that whole supply chain process of coal. Then we can have a one particular system or one particular where application where we can check the workflow of the total power generation process. So this is totally coal based. We have done that. This is what we can do for that. This present study, we can have that the future scope we can be used in steel, large power plants, industry based, and other models for the automation can also be implemented with barcode and RFID with extra accuracy. So here is the accuracy is the main concern, plus quantity and quality of your raw material. These are the references where these all the references where we have taken care of the studies of how the value chain, supply chain works, and we have got the references here. Other also 3 here, and which are almost old, 2010, but yes, 2015, but yes, this one, Romik Parekh Tanvisha RFID technology and based attendance management system, Department of Telecommunication Engineering, that I have visited personally, and I got the all information from there for the RFID particularly. And thank you very much. Any queries from your side?
Thanks for your presentation. Dear participants, do you have any question about the study?
Sorry?
Dear participant, do you have any question about the study? Okay, no question. Thank you again. I wish you success, dear Vinay.
Yeah, thank you very much.
Thank you again. Dear Kailash Shah, are you ready to present?
Yeah, sir, I am present.
Okay. I am sorry for the mistake. You can start your presentation if you are ready.
Can you ask Vinay to stop sharing, please?
Okay. You can share your screen.
Yeah, sure. Is my screen visible?
Yes. Please, you have 10 minutes.
Thank you. Yeah, sure. Thank you. So, good morning, the organizers of ISMSIT. Today, I'm going to discuss on my research area classification of attention deficit hyperactivity disorder using hybrid swing transformer and graph convolution neural networks. This is the content which I'm going to carry forward introduction, literature review, followed by motivation and objective, proposed architecture, data sets, result analysis, conclusion, and references. So what do you mean by ADHD? ADHD is nothing but attention deficit hyperactivity disorders. So if you see into the time scales, after 1990, these ADHD come into pictures, but before 1990, maybe from 1960 onwards to 1990, it was known as attention deficit disorder. And later on, it has been concluded that hyperactivity is also a phenomena which is coming from attention deficit disorder. That's why the H factor come into the this type of diseases. So what does this ADHD do actually? The ADHD, if you look closely, then it is for genetic and biology markers that challenges the identity diversities. So if you go towards clinical diagnosis, you will find that inattentiveness or attention deficit have 9 symptoms, out of which a few symptoms are careless, mistakes, not listening, uh, forgetting, like this type of things. There is hyperactivity and impulsive also have 9 symptoms. That is fidget, squirm, you roam here and there, often stand up from your chair. These are also some of the problem issues with ADHD disorders. Or a patient can have both also. Inattentiveness also as well impulsiveness. So what causes ADHD? So if you closely look into the human brain, which we say that it is a mixture of neurons. So if two neurons want to communicate, then they are communicating through messages. And these neurons which are responsible for ADHD are dopamine and norepinephrine. So dopamine is responsible for reward, risk, and impulsiveness, whereas norepinephrine is responsible for attention and arousal. So the scientists or the researchers are trying to discover what makes this ADHD genetic factor disorders. Here, if you see that the low-level transmission of messages or communication of messages from one neurons to another neurons causes the symptoms of ADHD. This is a factor which scientists are trying to find out why these low-level message communications are there, and this is still under a research where breakthrough is not yet gone. So looking into the previous slide, the brain functions causes the ADHD. Hence, we have taken the brain as the important factor for the entire research. So if we look into these 3 brain images, we will find that the first image where the temporal lobe, which is responsible for speech and comprehension, whereas then the second picture, the yellow region is a QNS, is linked for visual processing, and the last is for central sulcus, is responsible for the brain activity or functioning of different parts of the brain activities. So we try to get the MRI images of this brain, and I want to identify or differentiate between the healthy brain and with the ADHD brain. These motivators, also the objective also was clear now, that our aim is to establish a classification model that can assist the psychiatrist or psychologist in diagnosing and subtyping the ADHD based on relevant radiomics signatures. This is our proposed structure architectures, which where you can see here in the left hand side. This is the MRI images. ADHD MRI images is set as an input to this entire Swin transform, and the Swin transformer output is the feature which we get. This feature, extracted features, set as an input to the GCNN networks. In the GCNN network, we establish the weighted features of the input graph, and finally classification is used to classify whether the given image is a normal or ADHD. Coming to our methodology, the Swin transformer, which is responsible for feature extraction, is a self-attention mechanism. And there are 8 different stages through which we can get this feature extractions. The first one is image patching, where the input image has been patched, means split into MRI images, different patches of MRI images. Then patch embedding is there, which is linearly transforming the input images into higher dimensional. Then there is ASCII blocks, which is composed of SWSA. This ST blocks is composed of SWSA and FFN, where SWSA is shifted window self-attention, which is responsible for capturing global dependencies within the images. And FFN is a new multi-layer neural network which process the embedded patches into point-wise manners, applying nonlinear transformations. Then finally, there is a hierarchical processing, which is having a blocks or different blocks or stages of swing transformers there. And this swing transform operates on different resolution scales, allowing the network to capture information at multiple levels of details. One stage output is act as the input to another stages here. Then we use downsampling and upsampling that helps in incorporating both local and global contextual information. Finally, after so many hierarchical processing, we get the feature from the output representations, and this output representation act as the input to the GCNN. When we talk about GCNN, operates on a graph structured data, so the which handles the irregularity non-grid data also. It takes the advantage of relationship between the edges and then produces a weighted features factors, which is then been tried to classified using some neural network. So if you go back to my proposed architecture, you can see here, this is a three-phase entire hybrid model, where the first phase is for feature extraction, where the second phase is the graph convolution neural network for extracting the weighted feature again. And finally, the third phase is for the classification. This is the entire model is a three-phase architecture. This is the data set which we have used. So the famous data set ADASD 200 is being used here, which has been broadly classified into four labels. One is healthy control and the rest three is CHI. CHI stands for combined, hyperactive, impulse, and inattentive. And this has been downloaded from 5 different sites: New York, then Kennedy, then Peking University, and Neuroimages. See, PU is the 2 data set is from the same university here. Finally, the result analysis, we have compared our result with the state-of-art methodology, which is recent methodology, which has been used on these same data sets. And the accuracy which we got is 95 for NYU, 96.8 for KKI, 95.0 for NI, 94.3 for PU, and 90.1 for PU1. The right-hand side is the ROC curve, which we got, and you can see the ROC, which also confirm our accuracy through the AUC value, which we have achieved. In the conclusion, I would like to say that we have proposed a novel 3-phase hybrid transformer-based approach, which helps approach that applies in classification of ADHD data set. The proposed model has remarkably achieved higher accuracy on all the data sets. Swing transformation was very much effective in capturing the local and global informations, whereas graph convolution neural network capitalize on inherent connectivity pattern. In future, we will try to use other deep learning technique with other transformer to find out whether we can achieve 100% accuracy or not. These are the references which we have used in our paper.
Thanks for your presentation.
Thank you, sir.
Dear participant, do you have any question about the study?
No queries, brother. Thank you.
Okay, no questions. Thank you again. I wish you success.
Thank you, sir.
In your career.
I think we can move forward to the next presentation by Binay Kumar Garg, I think.
Okay. Dear William Olurotomi Falana.
Yes, I'm present, sir.
Are you present?
Yes.
Okay, you can start your presentation.
Just
Okay, go ahead.
okay. Good morning to everyone. And so today I'm going to be presenting the paper titled "Clinically Significant Prostate Cancer Classification" by using anatomical T2W sequence or plane and deep learning. So I'm going to discuss the goal, the introduction, the role of MRI and deep learning in prostate cancer detection and preprocessing, then the experimental setup, the experimental result, and then I'm going to conclude. So the major objective here is just to accurate classification of clinically significant prostate cancer. And we use models like DenseNet 201, ResNet 50, and VGG19 because of the density connectivity between the neurons, the neurons and the way they communicate. And also they are mostly suitable for medical image classification. And that's why we use these three particular deep learning models. Now, the use of anatomical MRI planes is because of the information that these planes contain. It's gotten by slicing the 3D images, and then there's a certain plane which belongs to the axial T2 weighted image. There's a coronal T2 weighted also image, and then there's the sagittal T2W weighted image as well. So these are the three planes that these images were annotated to. So then we now further classify them using these three deep learning models. Now, before we go into that, we want to see a brief overview of the prostate cancer. We come to discover that in Europe, prostate cancer is now becoming an issue because of its rise and the mortality rate that's associated with it. I'm going to be discussing about the clinically significant and non-significant prostate cancer just for information base. So the clinically significant prostate cancer is the one that has a higher risk of mortality, higher risk of projection and mortality, whereas the non-clinically significant one is the one that carries low risks and of mortality or death. So now the reason is because for the non-clinically significant prostate cancer, when detected, it can easily be treated and also be reduced to a level that can even be eradicated. So early detection or diagnosis of this can lead to treatment. So that's why we are using this two particular methods. So now we're going to talk about the MRI scans. So MRI scans have been used for several image detection because of its ability to capture, intense areas of region of concentration, and especially in prostate cancer. And deep learning also has also been used in several medical image classification, and has been shown to be one of the a good tool for detection and classification. So now, before we achieve this result, we did processing. We did first image slicing. So 3D images, these images were in 3D form. We used image slicer to slice them to be able to get them into the volume of 2D JPEG image. We did some image resizing, to be able to fit into the input of our models, and also for memory efficiency and network compatibility. And we use, as I've said earlier, axial, sagittal, and coronal anatomical planes because of their abilities to involve, comprehensive view of that prostate gland, and also help us understand the perspective for lesion localization along this plane, like similar features that are very important and structures that will be able to help us, dictate, differentiate between these two cases. So we did this experiment on MATLAB, using MATLAB framework, and on a PC HP of Intel Core i7. And the data set was something that was sourced online. Got data sets from a paper that was previously written, and they had this data set, so we were able to trace data set, and we got this information from there. So we did image augmentation to add to extra to make our data set more diverse, and to capture different pictures of it. So initially we had 690 images for training, 296 for test, and then after augmentation we had like 3,450 images for each of these. And we split this into 3 scenarios. We use the Actal T2W, we use the Sagittal T2W, and the Corona T2W. So as I've said earlier, the goal is for us to know which of these plane we can hit the accurate detection of prostate cancer in humans, mostly males. So now we discover from the Actal T2W, after using DenseNet, ResNet on this same particular image data set and VG19, we discovered that all of them were able to get a very accurate result, good result to some extent. But we discovered that ResNet 50 had an exceptional performance with 90% accuracy and AUC value of 0.98. And from the row curve, we can see that for ResNet 50, we can see that it was tending towards 1. That's why we add the value of 0.98 in this case. So, and others, it was far closer to 1 than others. Also, we did also for coronal T2W anatomical plane. We used DenseNet 201, ResNet 50, and VGD19 as well. They all had very good results, but we discovered that ResNet also performed very well in this classification with an accuracy of 91% and an AUC value of 0.94. We can also see the AUC value from the curve as well. The ResNet was tending towards 1, so which was made ResNet exceptional in that particular scenario. Now, the third scenario, we used the sagittal plane, anatomical plane. We did carry out the same experiment again using DenseNet, ResNet, and VGG19. We discovered that ResNet 50 also did exceptional well again, and it had an AUC value of 0.98 and 89% accuracy, so which was very good. Also from the row curve, we can see ResNet had a very good graph tending towards 1. So we concluded that all the deep learning models were able to differentiate, between clinically significant prostate cancer and non-clinically significant prostate cancer. We discovered also that ResNet performed well in effective distinguishing between these 2 scenarios of prostate cancer, and among the 3 deep learning models. And probably it's due to the ability of ResNet, to the feature extraction techniques and reuse of capability of ResNet probably made it to have a superior performance. And also, we discovered that the plain coronal T2W emerged as the most accurate and had an highest area under curve, that's the AUC value, among other axial, coronal, and sagittal anatomical planes. So, and then the general conclusion, we're able to distinguish between this clinically significant prostate cancer and the non-significant one using these 3 architecture, which all performed well. And we discovered that ResNet was the way to go, was one of the best architecture that was able to distinguish between them. And we also discovered that coronal T2W was one of the good, most informative plane that could be used in this diagnosis. So when you have a patient that's having prostate cancer, probably the best architecture to use is ResNet 50 in a deep learning model settings, and also the best plane to use to accurately detect this quickly is coronal T2W anatomical plane. That's the end of the first presentation. I don't know if I can go on with the second presentation. Is there any question?
Okay, thanks for your presentation, first presentation.
Sorry, I have a question.
Okay.
I am a beginner at the deep learning. That's why maybe it is a stupid question, but I want to ask which libraries did you use for these frameworks? I mean, TensorFlow or something else.
I use
Yes.
MATLAB framework.
But these frameworks are already libraries in MATLAB built-in.
Yes, there are already libraries in MATLAB. We just adjusted some of the parameters to
Yes.
make it.
Okay, I am asking this because of I am new. Maybe you can. Maybe one can also use TensorFlow or some other. For example, the
Like
Python
Python as well.
libraries.
Yes, definitely.
Yes. Okay. Thank you very much.
Thank you. Thank you very much. So I'll be going to my
Okay, you can start your second presentation. Please, you have 10 minutes.
Okay, so the second paper I'll be presenting is deep learning for comparative study of ovarian cancer detection on histopathological image. So we're going to quickly, because of our time, we're going to discuss about the goals, the introduction, the experimental setup, experimental result, and then our conclusions from this. So firstly, as I've said, ENSNet 201, ResNet 50, and VGG19 have models that does very well, especially on cancer images to be tested according to the literature. And also, we discovered that histopathological images are really good research images for cancer detection. Because of they contain microscopic details and that can be considered for diagnosis. So that's why these kinds of images are very good for detection. So let's quickly look at the brief overview of ovarian cancer. Firstly, ovarian cancer is ranked as the 5th leading cause of cancer-related deaths among women. Detection of this disease at early stages greatly improves chances of survival. And most women who develop ovarian cancer do not actually show noticeable symptoms at the beginning. So it's very, very, very difficult to be able to quickly detect these, especially because of the tendency for ovarian cancer not to show symptoms is very risky. And one of the most common methods that is used to detect ovarian cancer today is the combination of pelvic examination and blood tests, measuring the levels of protein in called CA125, which has proven not to be a reliable source of detection because of the kinds of results that comes out of it. Sometimes the research shows that sometimes probably 20% of the time, up to 30% of the time, it goes undetected. Patients with ovarian cancer goes undetected through this method. So our research question is now, how do we bring in these models to be able to accurately get ovarian cancer faster and more accurate? So our experimental setup. So this is the pathological image already in 2D, so it made it work very easier for us. So to further improve our experiment, we just did some little processing, such as image augmentation and also resizing the image to fit the input of our models. So we did this on a MATLAB framework on an Intel Core i7, and as I've said, the data sets were publicly available data set, logical ovarian cancer images. So we used 674 images for training and 288 images for testing. And after augmentation, we had 3,370 for training and 288 testing. Then we did the first, we were trying to distinguish between cancerous and non-cancerous ovarian histopathological images using DenseNet, ResNet, and VGG19 in this so each one was for each scenarios. So we tried out of DenseNet 201. We discovered that the AUC value was 0.97 with 91% accuracy. For ResNet 50, discovered that the AUC value was 0.99 with 97% accuracy, and we discovered that VGG19 was also at an AUC value of 0.99 with 98% accuracy. So from the confusion matrix, also look inward on how the detection went and know the ones with lesser errors. We discovered that VGG19 had less errors compared to ResNet, which came close to VGG19. So the true positive for the VGG19 was 142, the false positive was 1, and the false negative was 2, and the true negative was 143. So, and according to the row curve, also discovered that VGG19 tends towards 1, it was 0.99, which makes it the classification for VGG19 an exceptional one. So what was our key findings? So we found out that DenseNet 201, also ResNet 50 and VGG19 were able to detect and distinguish between cancerous and non-cancerous ovarian cancer, ovarian is pathological image cancer images. So they were able to distinguish accordingly. And also, according to the accuracy rankings, we discovered that VGG19 achieved the highest accuracy with over 98.96%, followed by ResNet with 97.2%, and DenseNet coming behind with 91.67%. For the true positive rate, we discovered that VGG19 led in the sensitivity with 0.98, and followed by ResNet 50 and DenseNet 201, which is indicating a strong performance in correctly identifying the cancer cases. For specificity, the true negative rate, we discovered that VGG19 and ResNet excelled in specificity. VGA19 slightly higher at 0.99 compared to ResNet 50 at 0.98, and DenseNet 201 at the low specificity in that regard. So, according to our area under the curve, we discovered that VGG19 and ResNet 50 demonstrated a high accuracy value of 0.99, indicating superiority in the ability to distinguish and detect. And also, DenseNet 201 scored an AUC value of 0.97. Now, our conclusions. So, from all the models that we tried in the comparative study, we discovered that VGG19 emerged as a standard model for showing exceptional accuracy, sensitivity, and specificity, and also AUC. And its ability to effectively identify both of these cases of this disease makes it a promising choice for this particular cancer detection, especially on histopathological image. ResNet 50 performance displayed commendable performance, especially in terms of specificity and AUC, making it suitable for scenarios whereby we want to prioritize the correct identification of negative cases. So there's some situations that want the negative cases, the correct identification of negative cases, in which ResNet 50 did well in that. So DenseNet 201 considerations. Why DenseNet 201 achieved a good overall accuracy? It turns out that it had a low specificity, and also there's potential for suggesting improvement in correctly identifying these non-cancerous cases. So DenseNet 201 is the least to be considered among these models. So VGG19 has excelled very much. Question.
Thanks for your presentation. Dear participants, do you have any question about the study? Okay, no questions. Thank you again. I wish you success in your career. Dear Wang Yu Wang, are you online? Dear Elizabeth Ango Fomuso, are you online? Okay, dear participants, thank you for your attending the session. Thanks for your contribution. I wish all success, all participants continue success. The session of the symposium is over. I would like to end this session. Have a good day, good luck.